We're going to finish off this fifth section of the introductory chapter, talking about how to factor when a value is greater than 1. So if we look at the factoring we did on Friday, x squared plus 5x plus 4, let's say, the a value comes in our generic form. A, B, and C represent these coefficients or these constant terms. And if you look at x squared, the number in front of x squared would be 1. So when a is 1, factoring is super simple. We just look for our multiples and what adds to be our b term. But when a is greater than 1, things get a little bit more complicated. So the method we're going to learn, and let's just double check and see how this is going to get more complicated. If I FOIL this, 2x squared minus 2x plus 4x and then minus 4. If you notice, so we have 2x squared plus 2x minus 4. If you notice our original parentheses, you can pretty easily tell that this first term, 2x squared, comes from the multiplication of the first terms. This negative 4 comes from the multiplication of our last terms. But the 2x in the middle kind of is a little bit more mysterious on how could we work backwards here. How could we figure out which pieces go into the parentheses based on that middle term. And you got to think a little bit harder to see that. So one way you can factor is definitely by using guess and check. Guessing what's going to multiply to be my first term. Okay, so the only thing that multiplies to be 2x squared is 2x and x. So we know our parentheses have to be 2x and x to lead with. And then use factors of your second term, 1 and 21, 3 and 7, and kind of see which ones are going to fit. In this case, we're going to equal 17 for our B term. You might be able to figure out, kind of do some quick foiling in your head and figure out that 3 and 7 will be the points, the numbers we're missing. However, guess and check gets a little messy. What about when we get to something like this? Well, 6x squared could be 2x and 3x. It could be 6x times 1x. 4 could be 2 and 2. It could be 1 and 4. And that's only if we have these nice numbers. I mean, 4. What if we had 8 or we had 16 in that spot? You're going to have a lot more factors that you could possibly choose from. So some combination of maybe this and this, or 6x and 1x and 2 and 2. Some combination is going to be what's filling in the spots in our parentheses. Instead of trying to guess which ones those are, let's talk about the unfoiling method. The unfoiling method is going to guarantee you get the correct factors. So I'm going to show you once how to do it, and then I'm going to give you some problems to test it out on. So we're going to test it on the equation we just saw, and I'll write out the steps for you. Step 1, hopefully you're familiar with seeing this before. We're going to find the value of your A term times your C term. So in this case, we want to do our 6 times 4 equals 24. Step 2 is going to be kind of like we did when we just had 1 in front of x squared. We're going to find factors again. We want to find factors of that A times C. So if we look at 24, 24 is 1 and 24, 2 and 12, 3 and 8, 4 and 6. Step 3, we're going to choose the factors that add to be the B term. So this should look very familiar to what we've already done. Before, we were looking for factors of our C term that added to be our B term. Now we're just kind of including in the differences this step 1. Instead of just C, factors of C, we're saying factors of A times C. So factors that add to be the B term. So if we're looking at 11x, that's going to be 3 and 8. Step 4, our factors are going to tell us how we are going to split the b term. Those are not necessarily the numbers that go inside of our parentheses. We're going to use those numbers, 3 and 8, and we're going to rewrite 11x as 3x and 8x. So we haven't changed any values. All we've done is split 11x into 3x plus 8x. We wrote it in a different way. If we bring down the rest of the problem, 6x squared plus 3x plus 4. Same problem. If you simplified this, it would be 11x. Step 5 is to group and find the GCF of each group. So if I group my first set of numbers and find the GCF, that's going to be 3x. And what's left in the parentheses would be 2x plus 1. In my second group, what can I take out of 8x and 4? Well, I could take out a 4. What am I left with? I took out a positive 4. I'm left with 2x plus 1. If you're thinking about what does it mean to have a greatest common factor, it means you're multiplying both. You can multiply both pieces, divide both pieces by the same number. Notice we have 2x plus 1 repeated, so we can actually, step 6 is take the GCF one more time. 2x plus 1 is the GCF. If we get those matching parentheses, so GCF would be matching parentheses. We get that GCF, 2x plus 1. What's left? Well, 3x. I took 2x plus 1 away from it. And this positive 4, those are going to be the fill-ins for the other two parentheses. So you notice that 3 and that 8 that we chose initially, they don't show up anywhere in our solution. The answer is not x plus 1, x plus 3 and x plus 8. It has nothing to do with our, not nothing, but it's not seen in our final solution. So if you need to rewind that and go through the steps again, make sure you understand where each of those steps is coming from. Could you do this with the problems that are x squared plus 5x plus 4? Absolutely. Think of what your a term is. A times c would be 1 times 4. So you're still looking for the factors of a times c. It's just that a is always going to be 1 in that case. So here's a second problem that I'm going to start for you, but I'm not going to finish. Remember, our first step is we want to take the a value times the c value. So 3 times negative 8. 3 times negative 8 gives you negative 24. And so we're looking for factors of negative 24. You need to pay attention to the signs, because if we have a negative number, we're saying we want the factors of it. We want one number to be positive and one number to be negative. So just realize when we're listing our factors, we don't know which one's going to be negative, which is going to be positive right now, but we're going to choose which set could add to be negative 2. Which set of factors? 1 and 24, 2 and 12, 3 and 8, 4 and 6. Well, if I chose 4 and 6, how could I get negative 2? Well, I could make 6 a negative 6. So when I choose my factors, I need to be careful about negatives and choosing the right number to be negative and positive. If I split this up, this is where I'm going to stop, but I'm going to split this up. Negative 2x becomes negative 6x and positive 4x. So that those factors we're choosing are just helping you split it up. Finish this problem for Monday, and then also pick one of these problems, at least one of these problems, to try to practice on your own the entire unfoiling process. Have a wonderful weekend. See you on Monday.